Let's look at some of the ways people affect the environment of plants in ways that they increase disease. One of the things we often talk about is location. Where are you going to plant? Is it in a place that's favorable for disease? Is it in a place that is favorable for plant growth? A golf course once where there were a lot of trees around the golf green. The trees stopped air movement. Trees increased humidity. This is very favorable for disease development. It's not that favorable for the plant. Location makes a difference. If you plant in a foggy area, you increase the susceptibility towards certain diseases. That makes a rather large difference. We can look at water management. How can we affect water management to decrease disease development? Water management makes a difference. When we irrigate, what time of the day do we irrigate? The concept is to always irrigate in such a manner that it helps decrease the amount of time that moisture remains on the leaves of the plant. If you look something like a golf course, you are going to apply irrigation to the golf course. We all know that dew sets up on the plant in the evening. It stays around all night long. It evaporates in the morning. If you wait until the early morning to do your irrigation, you are going to extend the amount of time that the plant gets wet. If you irrigate at 2 or 3 o'clock in the morning, what you end up doing is you end up disturbing the dew that's on the plant. You knock that off so the plant actually dries out quicker when the sun comes up. This picture was taken in the desert in Nevada. They were irrigating this particular area of plants with this particular amount of water. This is misting low to the ground. This was very early morning. You can see the long shadows. They weren't using the large overhead sprinklers. They were trying to get it so that things would come out and dry up very quickly. Not that they weren't going to dry up very quickly out there in the desert anyways. You can see that around it, you don't have a lot of good plant material. It's kind of a dry area. You do get plants growing in here because of the amount of irrigation. When they do this, they are monitoring all of these things to make sure that they don't have increased disease. We look at fertilization. In fertilization, if you apply just the right amount of fertilizer to get the plant to grow properly, it's not going to favor disease development. If you over-apply fertilizer, you get succulents. If you get succulents, that means the plant is now more susceptible to disease. Therefore, that's not a good thing. Now you got to go back and you got to check your fertilization. There are all sorts of other cultural practices that we do that we'd want to look at to make sure that they are not going to favor disease development. Another thing we do is we introduce pathogens. In the United States, the 3 major ones we talk about all the time are chestnut blight, Dutch elm disease, and citrus canker. These are absolutely monstrous. These are some guys back in the 1800s in a chestnut grove. You can see the size of these trees and they're absolutely phenomenal. You can't find trees like this anywhere in the United States anymore because chestnut blight came in and wiped them all out. This is a place in California. This is a newer disease that's coming in. This is a Phytophthora type. You can see that it is taking out a lot of plants out of the area. It's killing them off. This is due to an introduced pathogen. There was an introduced pathogen in Panhandle of Florida. Basically, it is a type of Laurel Wilt. It came in and it took out all of the red bays in northern Florida. We had several on our property that got knocked out in a year's time. Everything looked fine in the spring. By midsummer, the trees were dead. You would find the little frass coming out where the vector went in. This is down in Florida back in the 1920s. There was a citrus canker epidemic. Once it got started, it started going everywhere. They decided that the way they were going to take care of it is they were going to destroy everything and replant the crop. It worked very well back in those times. Since then, there has been a new pathogen that's come in that's almost identical to citrus canker. It's been almost impossible to get rid of. Over here, all they're doing is taking the diseased citrus, piling it together, and then they would burn it. They would let the whole area lay fallow for several years before they replanted. They replanted with new stuff that had better genetics. Introduced vectors. We see all sorts of vectors. You've got a psyllid up on the upper left. It can transmit a virus. You can see the virus on the plant to the right. This is another virus type disease that's transmitted by a vector. Over here we've got whitefly. Whitefly transmits diseases. Whitefly is very problematic in greenhouse environments. These are all introduced vectors that are problems. When you've got vectors, you've got to be able to look at how we can get rid of them. This is anthracnose on bean. Anthracnose on bean is seed transmitted. The seeds in here, in these pods, may come out having pathogen on them. If they come out having pathogen on them, they will look like the bottom row of seeds. If you plant this bottom row of seeds, that's going to be your primary inoculum. Before you plant the seed, you want to make sure that you treat the seed with a fungicide so that it doesn't allow for primary inoculum. The fungicide works very well, but otherwise you're going to have problems. How do we go and decrease primary inoculum? One of the ways is we do it through seed treatment. This is Diaporthy on soybean. It is a seed-borne disease. You want to make sure the quality of your seed is excellent. This is corn. You can see the amount of mold on this. You plant the seed, you will be transmitting some of that pathogen into the cropping environment. Anguina. We talked a lot about anguina. This is seed-borne. In the United States, we don't have a problem with anguina anymore. We know it's seed-borne. We know how to get the seeds out. We don't plant the seeds that have anguina in it. Now, it's a rarity to find it, but in other areas where they don't have all of that ability, it's still a problem. We have problems with vegetative propagation. When you vegetatively propagate a crop, you will transmit whatever pathogens happen to be on there. How many crops do we vegetatively propagate in the United States or in the food cropping area of the world? It includes such things as potato. That's all vegetatively propagated. Strawberry, vegetatively propagated. Sugarcane, banana, sweet potato, and the list goes on. All of these, if you don't have pathogen-free stock, it's as bad as having, or possibly worse than having, a seed-borne pathogen. Many different things that we look at as far as how we can propagate or transmit disease into the field.